Let's look at a couple examples of ellipses that are centered at the origin. So for each of these examples, we want to list out all the key characteristics, which those would include the center, which for both of these is going to be at the origin. We want to list the vertices and the co-vertices, the foci, the length of the major and minor axes, and then the eccentricity. Okay. If we're given a graph, we want to write the equation. If we're given the equation, we want to sketch its graph. Okay, so that's kind of what we're looking at here. So with this first example, again, we're given the graph. So we want to list out all the characteristics and write the equation. And the two things that we should observe about this graph right off the bat is we should see first that it is in fact centered at the origin. Okay, the x and y axes meet right at the center of this ellipse. The second thing that we should observe about the ellipse is that it is taller than it is wide. So it is stretched vertically more than it is stretched horizontally. Okay. And so that means that we have an ellipse that is oriented in the vertical direction. So we have a vertically oriented ellipse. And the equation for a vertically oriented ellipse is going to be x squared over b squared plus y squared over a squared, and that's all equal to 1. Okay, and just kind of the way to remember what that equation looks like is we always want a, if you compare a and b, we want a to always be the bigger value, and the bigger value goes with the variable that corresponds with our orientation. So a vertical orientation corresponds with y, and so we want the a, the bigger number, to go with the y. Okay, so it's vertical, y is bigger, a goes with y. Okay, so the b has to go with the x. All right, so in order to work through this problem, in order to write the equation and to figure out any of the key characteristics, we need to figure out the values for a and b, as well as the value for c. Okay, so a is the distance from the center to the, it's the largest radius. It's the distance from the center to the furthest point on the ellipse. So again, since this is oriented vertically, we want to find the distance from the center to the top of the graph, or you could say from the center to the bottom. So if the center is at the origin, then we are 6 units up to the top of the graph. So that a value is going to be 6. Okay. And that's going to also be related to our major axis, but we'll get that here in a second. If we look at the center, the distance from the center to the closest side of the ellipse, that's going to be our b value. So in that case, that's a horizontal distance here. So from the center to either side of the ellipse is a distance of 4. So that means my b value is 4. So we know A, we know B, I then need to find C. And so we had this little equation that connected the A, the B, and the C, and it was that C squared is equal to A squared minus B squared. So if we plug our values for A and B into this equation, we can figure out what C is. So C squared is going to be 6 squared minus 4 squared, which means C squared is 36 minus 16, or C squared is equal to 20. And so C is going to be the square root of 20, which we could simplify that. 20 is 4 times 5, and so the square root of 4 is 2. So we're going to have 2 square root of 5. So C is 2 square root of 5. Now I'll just give you a warning. Usually A, B, and C are not all going to be whole numbers. Some of them, at least one of them, is probably going to have a square root in them, if not more than one. So just get comfortable with that. All right, so we have enough information to write out our equation. Again, I know it's x squared over b squared plus y squared over a squared equals 1. So let's just plug our a and our b value in and then square them. So we're going to have x squared over b squared, which is 4 squared, or 16. So x squared over 16 plus y squared over 6 squared, and 6 squared is 36, and that's equal to 1. So we have x squared over 16 plus y squared over 36, and that is equal to 1. And again, because the 36 is the bigger denominator, and it's below the y, that means the graph is stretched vertically more than horizontal, because the 36 is with the y. So next, let's also list out all of our key characteristics for the ellipse. So the key characteristics for the ellipse are going to be our center, which we actually already know the center was at the origin, so 0, 0. We also need to list out our vertices, which there's 2 of those. We need to list out our co-vertices, which there's 2 of those. We need to list out our foci, so again, 2 of those. We then need to find the length of the major axis and the length of the minor axis. And then we want to find the length of the eccentricity. All right, so again, we know the center is 0, 0. The vertices are the 2 points, the coordinates of the 2 points furthest away from the center. And so in this case, we know that we have the 2 points, since the graph is stretched vertically, the 2 points furthest away are going to be at the top and the bottom of the graph. So just reading those off the graph, the bottom point would be 0, -6, so that's one of the vertices. And the top point on the graph is at 0, +6. Okay, so those are the vertices. They're the furthest points on the ellipse, the furthest points away from the center. And we can go ahead, once we know the vertices, we can figure out the length of the major axis, because the major axis is the distance, or the line segment, from one vertex to the other. So how far is it from one vertex to the other? How far is it from a -6 to a +6? Well, that's a distance of 12. Okay. All right, let's then find the co-vertices. The co-vertices are the points that are the closest to the center. And those 2 points, since this is a vertical ellipse, those 2 points are going to be measured horizontally from the center. So again, we can just read those 2 points. One is going to be -4, 0, and the other is going to be a +4, 0. Those are the 2 points on the ellipse that are the closest to the center, and they are oriented horizontally in this case, because the graph, the ellipse is oriented vertically. Once we know the co-vertices, we can also figure out the length of the minor axis, because the minor axis is the line segment connecting the 2 co-vertices. So how far is it from a -4 to a +4? That's a distance of 8. Okay. All right, next thing we need to figure out is the location of the foci. Okay, the foci are 2 points that are on the major axis, which is a vertical line in this example, and the distance from the center to each foci is measured by c. So in this case, c is a 2 square root of 5. So that means I have to start at the center and go up a distance of 2 root 5 and down a distance of 2 root 5. And since we're traveling in the vertical direction, because that's our major axis is vertical, because the graph is vertical oriented, that means the foci are going to have the same x coordinate as the center and the vertices. It's just the y coordinates that are going to be different. So one focus point is going to be 0, -2 square root of 5, and the other is going to be at 0, +2 square root of 5. Okay, so again, the foci, the vertices, and the center should all be in the same line. In this case, that's a vertical line, so it's only the y coordinates that are going to change. They should all have the same x coordinates. Okay. All right, the last thing that we need to look at is the eccentricity for this example. The eccentricity is a measure of the ratio of 2 distances. It's the measure of the distance from the center to the foci divided by the center to the vertices. So we could think of E being the fraction C over A. Okay, so we're just going to plug our C and our A value in there. So the eccentricity is going to be 2 square root of 5 divided by 6. And we could go ahead and simplify that. We could also just plug it into our calculator. So 2 square root of 5 divided by 6 is going to be roughly 0.75. And so I think we saw earlier the eccentricity has to be a number between 0 and 1, not including 0 and 1. If the eccentricity is 0, then we actually have a circle. And if the eccentricity is 1, we have something else. Okay, so the eccentricity is always going to be a number between 0 and 1, not including the 0 or the 1. Okay. All right, let's look at one more example here. This time we're given the equation, and from that equation we want to identify all the components, all the key characteristics, and then we want to sketch a graph. So remember the key characteristics. We're going to need to figure out what is the center, what are the vertices, the co-vertices, the foci, the length of the major axis, the length of the minor axis, and the eccentricity. Okay, so those are the key components. To get all of that stuff, we need to figure out what the values are for A, B, and C. So we need to figure out A, B, and C, then we can figure out all the characteristics, and then we can sketch its graph. Okay. As we look at the equation, look for which denominator is larger. So we're looking at a 49 and a 4. So our equation is x squared over 49 plus y squared over 4 is equal to 1. The 49 is the larger denominator, and that 49 is with the x. So that means this is actually a horizontally oriented ellipse. So everything is stretched in the x direction. So the major axis is going to be horizontal. The minor axis is going to be vertical. That means the vertex, the foci, and the center are all going to be along a horizontal line, which is different than the example we just looked at. Okay. So A is the bigger number. So A squared has to be 49, which means A is 7. B squared has to be 4, which means B is 2. So how do we find C? The same way, C squared equals A squared minus B squared. So C squared is going to be 49 minus 4, or 45. And so C is going to be the square root of 45, which 45 is really 9 times 5. So we could say that C is going to be 3 times the square root of 5. So now that we know A, B, and C, we can go ahead and find all of our values, all of our key characteristics. In both of these examples, we're assuming that, or we're looking at examples where the center is at the origin. So this is still at the origin. The vertices. Again, the vertices are always measured from the center outwards a distance of A. And since this is horizontal, a horizontal ellipse, the A value is the horizontal measurement. So from the center, we're going to travel to the left and to the right a distance of A, which is 7. So our vertices are going to be at -7, 0, and a +7, 0. Okay. From there, we can also figure out the length of the major axis. So the major axis goes from one vertex to the next, to the other. One is at -7, the other is at +7, and that's a distance of 14. So the major axis has a length of 14. And again, remember, because this is a horizontal oriented ellipse, the vertices are horizontal to each other. Okay, they're not vertical. That also means that the co-vertices are perpendicular to that. So if the vertices are horizontal, because the graph is horizontal, it means the co-vertices are vertical. And the co-vertices are based off of the b value. So vertical values, vertical components, vertical distances, and the distances too. So from the center, which is at the origin, we're going to have 0, -2, and we're going to have 0, +2. So those are the co-vertices. The foci are in line horizontally in this case, because it's a horizontal ellipse. They're going to be horizontal in line with the center and the vertices. So that means their y-coordinates are all going to be 0, and the x-coordinate comes from the c. So we're going to have -3 square root of 5, comma 0, and we're going to have the +3 square root of 5, comma 0. Length of the minor axis, that's just the distance between the co-vertices, which if they're at -2 and +2, their length is 4. And then we have to find the eccentricity. With the eccentricity, again, is the value of c divided by a. So that's going to be the square root of 3 square root of 5 divided by 7. We really can't simplify that at all, so we'll just go ahead and crunch that into our calculator. So 3 square root of 5 divided by 7, we could round that as 0.96. We'll just round it to 2 decimal places. Okay. All right. And so again, that eccentricity just measures the degree to which this ellipse is stretched. So a value closer to 0 would be more circular, less stretched differently. Whereas the closer to 1 it's going to be means we're going to have an ellipse that's stretched more and more in one direction compared to the other. So this is pretty close to 1. So this ellipse should be quite a bit longer in one direction than it is in the other, which hopefully we'll see that as we graph it here. So I know the center is at the origin. I know the vertices are at -7, 0, and +7, 0. The co-vertices are at 0, 2, and 0, -2. And so if I plot those 4 points, the vertices and the co-vertices, that will basically show me what the ellipse is going to look like. And so I'm just going to connect those 4 dots together. So we're going to go from one vertex to the co-vertice and then back around. So if we look at this graph, left and right horizontally, it goes from -7 to +7, and vertically it goes from -2 to +2. So this is, looking at that graph, it is oriented horizontally because it's much longer horizontally than it is vertically. And again, that shows up in our eccentricity being closer to 1 because it is quite a bit wider, quite a bit longer than it is vertically tall. Okay, and so again, that's kind of where we see this horizontal orientation in our ellipse.